my favorite people. It's Miss Berger.
And Miss Lamb.
And we're going to talk to you today about a type of transformation called a dilation.
A dilation.
Dilation. So our learning target.
I can define and recognize dilations.
Well, Miss Lamb, what is this thing that you keep talking about? What is a dilation?
I always, when I'm teaching this, I always talk about my own experience when I go to the eye doctor. And the eye doctor wants to look into my eyes, but they're kind of tiny, you know, and you've got to the pupils little, and they dilate the eye to make it proportionally larger, that bigger opening, so they're making it bigger so that they can look into it from their machines. And so some of you who might have gone to the eye doctor, some of you with glasses, you definitely went to the eye doctor.
It's true.
Usually they get your eyes dilated. Now, it makes it temporarily bigger proportionally, but then it reduces down to its smaller size. So a dilation is taking a shape, keeping the shape, but making it either larger or smaller.
Right? So they would be similar shapes, right?
Yep, similar shapes. Ooh.
Not congruent though.
Not congruent. Similar.
Right? So when we dilate a figure we usually use a coordinate plane, right? To kind of show that it's bigger or smaller. Mm-hmm. It's going bigger or smaller. And if it's going bigger, we're really multiplying it by a whole number, right? So it's kind of like times a whole number.
Mm-hmm.
So like if I wanted to make it twice the size, that's times 2. I can times 4, times 10, whatever, right? When I'm making it smaller, I'm really multiplying by a fraction or a decimal equivalent, right? So I could cut it in half, right? Half would make it smaller. So we multiply the numbers by a decimal or a fraction equivalent.
Right.
Yep, so we're going to kind of bring back in all of those skills.
Now the reason we have this particular graph is just to show you that sometimes dilations will be shown to you in maybe a test or a quiz or something where they're actually inside of each other, like one's the original.
So like blue was the original.
Original, and we know that it's the original because the prime, the one with that little tick mark right there, is the new shape.
Yes.
Okay, but sometimes they do it like this, where we have the original right here, and they made it larger, but they graphed it over here. So I just want you to know
it's called the prime.
This is the prime, the new shape.
Is called the prime. The prime has that little one tick mark.
Yeah,
you see right there, it's teeny tiny.
Teeny tiny, yeah.
And that shows that that's the new shape.
The new shape. So I just wanted to show you, you can see it either way.
So here we made it smaller.
Reduction.
And then here you made it bigger.
Enlargement. And you do see those words a lot. Reduction and enlargement.
Got it.
Okay.
I'm on it, Miss Lamb.
All right, now.
All right, so let's show an enlargement and how we actually kind of figure out an enlargement.
You want to tell me the numbers and I'll write them?
Sure. So first we're going to start with the ordered pair. So ordered pair D is at 2, 6. Ordered pair A, I should have probably done this in order. A is at 2, 1. B is at 5, 1. Remember we go over and then up and down. And then C is at 5, 6. Right, so that's our original shape, and those are the ordered pairs for our original.
Do you want me to keep writing on this side?
Sure.
I'll do the prime. So there's the D prime.
Well, here, let's do a different color, Mrs. Lamb. What is happening over here? Hold on.
Oh, because I was
Sorry,
writing.
I didn't realize I did that if you were writing. Well, here, let's do it in the color we can see. Okay,
I'm going to, oops. Wow.
That's okay, guys. It's hard up here sometimes. All right.
D prime, A prime, B prime, and C prime. And Miss Berger, what are we going to enlarge?
Do you want to make it twice?
Let's do twice.
Twice. So twice would be times 2. So what we have to do is multiply each part of the ordered pair times 2. So we're going to do X times 2, Y times 2. So 2 times 2 is 4. 6 times 2 is 12. 2 times 2 is 1 times 2 is 5 times 2 is 1 times 2 is 5 times 2 is 6 times 2 is. Okay, so then we have to graph. Now some of these are going to be a little off the graph, but we'll make it work as best we can, right? So then we just re-graph the new ordered pairs, the primed ordered pairs, onto our graph. So if I were to start with, let's start with A prime.
Okay.
Is that 4, 2? So I kind of go here, 4, up 2. I'm going to start there.
Okay.
And then let's do D for 12.
4.
So 4, and then, okay, so 9, 10, 11, 12.
There you go.
Why not? All right, and then now we have 10, 2.
Okay, 10, 2.
Right, and then 10, 12.
And then 10.
Oh, sorry, I was just putting
Okay.
my little, I'm sorry.
No, you're fine.
Nope, we're working together.
All right.
B1,
Prime. Yep.
C1. And then we just connect our ordered pairs to show our new rectangular shape. Yep. So we dilated it. We enlarged it.
Enlarged it.
An enlargement.
Yes.
All right, but can we show a reduction? So same process. But nice thing is that these are already done for us, right? Our ordered pairs are already here. Little hard to see, but this one's at, and I think I'm still right. This one's at -4, +3.
This is at 4, 3. That one down
This
there.
one's at -4, -3.
This one is at 4, -3.
So what type of reduction should we do? Should we just cut it in half?
Let's cut it in half.
Let's cut it in half. So our new, let's call this A. Our new number, if I cut it in half, -4 divided by 2, or if I multiplied by 1/2, right? Multiply by half, divide by 2, same Z's, would be -2. 3 divided by 2, 1.5.
Okay. If I call this B, so this would be, whoops, this is B here. So B prime, well, God, I have the same numbers except the only difference is these are both positive.
Yeah.
So I've got 2 and then 1.5 for B prime.
Okay. Do you want to make that one C or mine?
I'll go C here.
Okay.
We'll make this one C. So C prime will be, again, 2.
2.
But this time it's -1.5 because I divided by 2 or times by.
D prime would be -2,
2.
-1.5.
Wow, we did kind of the same
So
math.
then now we just have to graph it, right? So I go -2, up 1, and I'm kind of hanging out in the middle.
Yeah. Over 2, up 1.5 for B prime.
You want to do your C?
Oh yeah, C prime. 2 and then, okay, 1.5 right there.
And then -2, -1.5. And then if we just connect our dots to the best of our abilities,
B prime.
we have our
C prime.
reduced
A prime.
rectangle.
Yep. We have dilated it, and this one fits like.
Can I show them one thing real quick?
Oh, Mr. Lamb wants to come in from the side.
Oh
and show
yeah,
us.
this time you get all three of
Oh,
us.
snap. Now we're talking.
I was going to show this on the other one too, but since this one does the same thing, obviously. So if you wanted to make sure you drew it right, if you count from here to here, you have 1, 2, 3, 4, 5, 6 squares. If you count from here to here,
1, 2,
2,
3.
Oh.
you have 3 squares. So then you cut it in half.
4, 5,
So the
6, 7,
distance
8.
between them should be
1,
half.
2, 3, 4.
Oh,
That was
how
fun.
crazy. Thanks for that little
Thanks.
tip, Mr.
Yeah.
Lamb. All right, so if you feel like you're confused, go watch that next video. But if you got it, and I mean, how could you not after that last tip?
Sure.
There